there was no grid at that time, but he thought about that. I want the electricity to be produced in Bhatta. And I think this is possible now with this high technology. With this, in fact, 1997-98, I went, whenever some idiots invite me to America because they pay for my fare and everything, so I give lectures. So I gave lectures at MIT. And I was very impressed with the technology that I saw in the media lab in MIT, and where for the first time this rapid prototyping was coming. Rapid prototyping is a process in which you have a desktop manufacture. You're supposed to put in certain chemicals or certain things, and out comes a finished product. And it is coming up now much faster. It's called the 3D printing. So you can have donuts. Now you can have donuts, you just send a donut design to the computer, to the internet, and you can have a donut because this donut material is there. And so just like the printing, they have now this process. And this is my dream, that in future we will have manufacturing units in rural areas, which will be very high tech, using the local materials, putting in this machine, and out comes out whatever you want. This is rapid prototype. I don't need to have a complete plant only for toothbrush. That is a multi-purpose plant, just like agriculture. An agriculturist is a multi-purpose entrepreneur. From the same piece of land, he can produce anything. So sweet sorghum, tur ki dal, sugar cane, everything. The same thing I expect, I dream of. We will have inputs coming in, just the basic chemicals, and output will be anything, a comb or a toothbrush or anything. This is the dream. And I think that is what India can teach the world. This decentralization, because we are losing, we are becoming just like, we are following the American system, the European system, that the very high-tech, high megapolis, urban systems. But I believe that we should continue with our rural areas, with our farms. And I'll give you again an example. The hallmark of evolution is size reduction, increase in complexity and efficiency. That's how the life evolved. We came from dinosaurs, and look at what we have come. The same thing happened with the cell phone. I'm sure some of you know, in 1990 when the cell phone came, this was this big. This was very heavy. It was directly connected to the Iridium satellite. And in fact, I was in Denver at a time giving a lecture, and this person was showing very nicely that, listen, I have arrived because I have this. And he could make 1 or 2 phone calls. Today, look at our cell phones. You can't even see the cell phones. And this is taking place in every technology. Whether it's a power technology, whether it's anything, it's always a size reduction, complexity, increase in efficiency. And this is how the evolution of our design should take place. Now I'll give you some few examples of what we have done in our institute. Nothing, Sudhendraji was very kind, but I have come to this this level in my life where, as my friend Jairam Ramesh told me, that people who can't do physics, they do metaphysics. And that's what I have. So I preach, but I don't follow that. But I'll show you some few examples of what we are doing. When I came to Phaltan in 1981, the first thing that attacked me, I really felt, because Phaltan in those times had hardly any electricity. I used to sit in my office, totally perspiring, and with no electricity. And we had to use the kandil, the lantern. So I started thinking about how to improve that lantern. This was 1981-82. So the first thing that I thought that maybe can we go for a fuel which can be grown locally and which could be a substitute for kerosene. So in 19, I'm very proud of that, because I take great pride because of our work, there has been now a very major shift all over the world where they are talking about alcohol as a cooking and lighting fuel. And we started this work way back in 1980s. And a lot of our papers and etc. came on that. So when I looked at it, naturally sugarcane was a classical example in Phaltan, because Phaltan is a very rich sugarcane growing area. But then this issue of food versus fuel, luckily we thought about it at that time. So we thought that what can be the fuel. And so we hit upon sweet sorghum. Sweet sorghum was introduced in India through our institute in the early 1970s, but as a source for sugar, because Maharashtrian areas with a lot of water into the sugarcane farming, has made a lot of soil very saline. So the idea was to have a crop which will require much less water. And sorghum is a dry land crop. And sweet sorghum is a variety in which you put the genes where there's a very high sugar content in the stem, but still requires much less water. In fact, sweet sorghum requires 50% less water than sugarcane for the same amount of sugar. So per unit of sugar, per unit of water, sugarcane is the highest producer of sugar in anywhere known for mankind. So we started working in 1980s on sweet sorghum for breeding, etc. As an engineer, I said, what can we do? Because if you are going to produce alcohol, then 80% of the energy in alcohol production goes in distillation. Since I did my Ph.D. in solar energy in the United States, so I thought maybe we can use solar energy for producing, for distilling. So in 1987, we set up the first pilot plant in the world, which ran completely on solar energy to produce ethanol. So this is a pilot plant that you see. It had solar collectors, and this is a pilot plant. It produced 50 liters per day of 95% pure alcohol. At the time, nobody thought that alcohol could be produced on this scale from sweet sorghum, because sweet sorghum was not known. And then when we did this work, we also realized that large number of distilleries come in rural areas. They pollute because every liter of alcohol produces 15 liters of effluent, which is extremely foul smelling, which is dark in color, and most of the times, a lot of these sugar factories, because the pollution control board does not allow them to pollute, so they are supposed to put in very good equipment of producing biogas, etc. But a lot of sugar factories, they put it into the fields and etc., and it spoils the fields, kills the cattle, and all sort of things. So then we developed a technology using solar energy to detoxify this distillery waste. So this is a photocatalyst. You mix with this effluent, and the UV radiation from the sun breaks with this photocatalyst this effluent. So on this last so this is how the effluent looks like. It's a very foul smelling, and we diluted it by 5 times, and in 2 days it became not completely colorless, but enough to be put in the water bodies like a canal, etc. That's the product. So this catalyst is 90%, we are able to get it. Because of 10% loss, it is slightly costly. A couple of distilleries have shown a lot of interest, but so this is a pilot plant that we set up in our institute. It's just used to circulate, and then after we developed the alcohol, then the next question was how to use this alcohol for cooking and lighting. So we started this work in late 90s, where I developed for the first time a stove. Now the whole thing is running on daru. This is 50% alcohol, 50% water. This is pure daru, what you distill in the rural areas. The idea of this came from an engineer of mine. He came from Uttaranchal. So anytime these people come, I ask them, I said, what is the major problem in your area? So he says, drinking. Most men folk produce alcohol, they drink, they beat up their wives, and their wives have to go for 5 to 10 kilometers to collect firewood. So we start thinking that can we kill 2 birds with 1 stone, to use that alcohol for cooking and lighting. Now that is easier said than done, because producing a very high flame and producing a very high quality light is very difficult when you have 50% water and alcohol. And supposing some of you are engineers, you will realize that burning 50% alcohol water is a very, very tough, challenging problem of mechanical engineering, combustion, etc. So we developed this stove. We showed it to a lot of people. We tested this in with around 60 or 70 local laborers, and they loved it because it was just like a LPG stove with a switch of the button. There's no smell, no more smoke, everything was very clean. The major problem was that we had to supply the alcohol to be put in, which is basically you can drink that. Though if we have put methanol and etc., but still you can drink it and then